Hi, ladies and gentlemen. I'm so sorry that I couldn't be here today. I'm at the second half of that training that I was at before break, but I hope that you had a wonderful spring break and you feel well rested and you are ready to make the final push towards summer break. So today we're starting a statistics unit. The substitute should have given you a packet, and this includes notes and homework. So I'm going to run through some definitions with you guys, and then I'll do some examples with you, and then the examples that I don't do will be up to you to try. So some will be kind of like classwork, like we would do together, and then some will be on your own homework. So more of this will be on your own than usual, but the lucky thing is that this is just a lot of vocabulary. It's not a whole lot of math skills, so to speak. So let's go ahead and get started. So I'm sorry I've got to come at you with a lot of vocabulary today. The first word, we're going to start with population. So you guys know what the word population means, but in the context of statistics, a population is a group that we want information about. So say we want to know information about all of North Carolina, or we want to know information about all high schoolers in the nation. So a parameter represents the population, and it's what we want to find out. So a parameter represents the population. So I'm not a huge fan of this definition. Another way that I would define parameter, it's typically represented by Greek letters, but it is what we want to know. About the population. So say that my population is Apex Friendship High School, and what I want to know is how many students go off campus for lunch. That would be the parameter. So here's the thing about learning about parameters. They're very impractical to find out. Say that I wanted to know in the nation how many people drive a Chevrolet. Would it be practical for me to talk and find out about every single person in the nation? Well, on second thought, there are records of what kind of cars people own, but what about ice cream preferences? There's not records of that. You can't talk to everybody in the population. It's not practical to talk to everybody in the whole school, everybody in the whole state. So we take a sample. And so a sample is a subgroup of the population. So instead of talking to everybody in the nation, I could talk to 100 people from every state, and that would be a little more realistic. So a statistic is a value that represents a sample. So a statistic hopefully represents our parameter. So say, for example, I wanted to know the favorite ice cream flavor at everybody at Apex Friendship, and I used you guys as my sample. So say that, I don't know, 75% of you liked vanilla ice cream. Does that mean that 75% of the whole school likes vanilla ice cream? Maybe, maybe not. It could be higher, it could be lower. So what we want to do is we want to make sure that we choose a sample that is as representative of our population as possible. That way our statistic gets as close to the parameter as we possibly can while still being inside the realms of what's practical. So a survey is a study that obtains data from a sample in order to estimate population attributes. That's what we just talked about. So experimental design is just another vocabulary term. We're kind of switching gears, but it's an experiment is a plan of randomly assigning experimental units to treatments to establish a cause and effect relationship. So experimental design could be having plants listen to different types of music to see how much they grow, and then establishing Beyonce causes plants to grow faster and Nickelback causes plants to die. That would be a cause and effect relationship determined from your experiment because you did something to the plants. You played music for them. An observational study is another way to obtain data, but it's different from an experiment because you don't do anything. You don't add to the situation. You just observe what's already going on without any intervention. That's the key there. So individuals are observed, and data is recorded without any intervention. So, experiment, you intervene to determine cause and effect. Observational study, no intervention. You just get data based on something that's already going on. So if you observed a plant growing in a field with no trees and a same plant growing in a forest, if you observe the differences without imparting your own catalyst on those. So sampling design is the method that we use to choose a sample from the population. So here's what that means. That means when we design our sample, we want to make sure that our sample represents the population to the best of our ability. And that way our statistic gives us the best representation of our parameter. So there's a couple different types of sampling. Unfortunately, these are just vocabulary terms that you're going to need to memorize and know how to apply in given situations. I'm sorry, I'm not a big fan of memorization, but this is just part of statistics. So one type of sample design is called convenience sample. And so convenience sample means it's easy to do. If something's convenient, a convenience store is right around the corner. It's convenient for you to get to. So subjects are taken from a group that is conveniently accessible to a researcher. So for example, you guys are convenient to me. You're right here. I don't have to go anywhere. So you guys would be a convenience sample. Is that always a good sample? Well, think about, what if I want to know something about Apex Friendship High School? Are you guys a good sample? Are you the same distribution of males and females? Are you the same distribution of grades? No, because there's no freshmen nor are there seniors in here. So convenience samples aren't always the best representation of the population. So example, I could distribute a survey to students in my class. So the problem is convenience samples are really representative of the full population. Voluntary response is a little bit different. Subjects select themselves. So say, for example, I wanted to do a study on students' favorite, movie. And so I put a box in the cafeteria, and there was a place to fill out your favorite movie and drop it in the box. So without any incentive, just because I wanted to collect information, do you think people would do that? Well, people usually only do these types of things when they have very strong feelings. So for example, have you ever gotten a receipt from a restaurant and it says, fill out this survey, let us know how we did? People tend to only self-select participation in a survey when they feel very happy or very unhappy about the results of their experience with whatever they're being asked about. So if I went to a restaurant and had a wonderful experience or a terrible experience, and to be honest, in the world we live in, especially when people are behind the protection of a computer screen or a phone, people are far more likely to be negative and share negative opinions more than anything else. So voluntary response results in a lot of negativity. So the example here is you can make a TV announcement asking for volunteers to stop by and pick up a survey, or I could ask advisors to pass out surveys and have students return them. So again, those with strong, especially negative opinions tend to volunteer. So these are called non-probabilistic sampling because there's no probability like related to choosing your sample. You simply choose people that are convenient or choose the people that volunteer themselves. And so in both cases, these tend to be pretty bad representations of the population. You're not going to get a very good snapshot of what the entire population looks like if this is how you choose your samples. However, there are some probabilistic sampling designs. So those involve random selection, and that's the key word. You randomly select, and that guarantees that everyone in the population has an equal chance of being chosen. So there's a couple different ways to do this, and depending on the situation, you might choose one way or the other. The first is called simple random sampling. It's about as basic as you can think. All groups of the sample size, or of the sample, have the same chance. Whoops, wrong word there. It's like I'm really here making mistakes. All groups of the population. That should be the word population. All groups of the population have the same chance of being selected, and we might add to that for the sample. So an example of that is if I wanted to do a survey of Apex Friendship High School, I could generate a list of student ID numbers and then randomly select 15 students. The more students you select, the better representation it's going to be. The bigger the sample, the better representation. But if you randomly choose, if we put names in a hat and pick them out, that is a great way to get a decent representative sample. There's another way we could do it, though, and it's called stratified. Stratify is just a fancy math way to say that we are going to sort. So, a stratified sample, the researcher divides the entire population into homogeneous subgroups. Homogeneous is just a fancy word for like or same. And we call those strata. Those subgroups are called strata. And randomly selects the groups proportionally from the different strata. So here's what that means. If we divide all the students in Apex Friendship into 4 homogeneous, that means like or same groups, they all have in common that they're freshmen, sophomore, juniors, and seniors. And then from each of those groups, you choose random students proportionally from each grade level. So you choose more freshmen than you would seniors because there's more freshmen in the population than there are seniors. So another way to do it is you could split them into male and female and then choose proportionally from those stratas of male or female. So the long to short is you sort them into strata and then you choose proportionally random students from each group. So what that does is that guarantees that you're going to get a pretty representative sample of your population because you're going to make sure that you get a certain amount of freshmen, sophomores, juniors, and seniors that represent Apex Friendship. So a cluster sample is a little bit different because the entire population is divided into heterogeneous. So heterogeneous means mixed up, essentially. They're divided into mixed up groups or clusters. We call them clusters. So we have lots of mixed up groups in our school already. For example, classes right now are clusters, and here's why. In any given class right now, you could have multiple grade levels. You could have different proportions of male and female. There's different demographics. And so unless we manually sort them into homogeneous groups, you guys are grouped heterogeneously into clusters. So when we do cluster sampling, all individuals from a cluster are chosen for the sample. So the difference is, for stratified, what we just talked about, you would choose random people from the stratas. But for cluster samples, you'd take a whole cluster. You wouldn't just choose a couple, but you'd say, okay, I'm going to survey Miss Jones, Miss Allen's, and Miss Davis's math classes, and those would all be the clusters. So, systematic random is a little bit different. A researcher selects a number from 1 to k. I know k is not a number, k is a placeholder, so a number from 1 to infinity at random. They call it k, and then they select every kth person. So, for example, randomly select the number 7 and select every 7th person on your roster. So that's systematic because you have a system about it. So here's the thing. Even if you pick the perfect sample to represent your population, there still could be some problems. Just because you are making a survey and you do everything right doesn't mean that the people who are responding are going to do everything right. Also, at this point, you may have noticed that I have crossed out some stuff. Obviously, I'm skipping over it so you can do the same. So, bias occurs when a sampling method favors an outcome. So, convenience sampling, cross that out, that's a type of sampling. So there, even if you do everything perfect, you pick the perfect sample. You've got your group of kids you're going to survey from Apex Friendship. You've got 40 kids. They perfectly represent the whole population, male, female, grade levels, demographics, everything. Even though you did everything right, they could still mess up things for you. Here's the first thing. Undercoverage. When some groups of the population are left out of the sampling process. Okay, so I lied. This one is your fault. So if I said, hey guys, I'm doing a survey and I want to know the favorite pets of students in Apex Friendship, and I only ask the males in our class, would that be a good representation of the students in Apex Friendship? No, because there was a whole group, females, that was not covered. So undercoverage means that a group is undercovered or not covered at all. So people are left out of the sampling process. I'm going to skip down to non-response bias. We're going to go back up. Non-response is a little bit different because a member can't be contacted or refuses to respond. So same scenario. I want to know about the favorite pet. Refuses, not refused. Changing tenses here in the middle of sentences. Say I want to know about the favorite pet of students at Apex Friendship. And I ask all the males and the females, and the males say, hey, we're not answering. We refuse. Is that going to be a good representation of all the students at Apex Friendship? No, it's not. But that's not on the surveyor anymore. That's on the people being surveyed. The guys are refusing to be surveyed, and so that's going to skew the statistic that I get. So that's a different type of bias. Under coverage, it's my fault. I didn't ask the girls. Non-response bias, it's the guy's fault if they refuse to answer. So two different scenarios. Now, voluntary response bias. We talked about it as a sampling method, but we didn't really talk about it as a type of bias. So sample members are self-selected. And these are people with very strong opinions, usually negative. All right, response bias. When individuals lie. So here's the thing. What if a policeman came into this classroom and said, please raise your hand if you've done illegal drugs within the last 30 days? Now, I hope nobody's raising their hand right now. I don't want to know. But what would happen is that people would lie. People don't like to admit to illegal, racist, unsavory, unpopular opinions. People don't tell the truth. So especially if there's a chance that their responses will be publicized or sent to anyone in who could get them in trouble legally, people aren't going to tell the truth. So when individuals are dishonest, or may answer the question untruthfully, which is the same thing. That's a bit redundant. And then wording of the question is a weird one, because have you ever had somebody put you in a position where they ask you a question and they clearly want you to say a certain answer? It's very important that a question is worded in a way that can't direct people to answer the question the way they want them to. So if I said to you, are you going to vote for candidate A like everyone else, or are you going to vote for candidate B that nobody likes? That's not a fair way to word the question, because even though I know you guys are strong thinkers, you think for yourself, people are inclined to go with the majority. They want to be liked. They want to go with what everybody else is doing because we all want to be accepted. So wording of the question means that a poorly worded question can result in response bias. Response. All right. So you've made it through all the definitions. I'm very proud of you. Let's look at some examples. All right. So we're going to talk about different sampling methods first. So remember, simple random, that means names in a hat, essentially. Cluster, that means that heterogeneous groups already exist, so like a class of students. Stratified means that we are sorting them ourselves into like groups. Convenience means that we're just picking the people that are right there. Voluntary response means people are self-selected, and systematic means we're choosing every nth person. So here we've got a scenario. Every fifth person boarding a plane is searched thoroughly. What is that an example of? Well, every fifth person is every kth person or nth person. I forget the letter we used, but that is systematic, because you have a system. Number 2, at a local community college, 5 math classes are randomly selected out of 20, and all the students from each class are interviewed. So there's 2 clues here. The first is that 5 math classes are selected, which lets us know, are math classes homogeneous or heterogeneous groups? They're heterogeneous because